Hello, everyone, and welcome to this webinar by Intezer. I appreciate your time. Thank you very much for joining. I'm Shaul Holtzman. I work at Intezer, and among other things, I'm in charge of the Community Edition. The purpose of this webinar initially was to provide some additional demos and information for the community users, but we were happy to see that not only our community users have joined, but more people, and of course everyone is welcome to see Intezer and some more interesting features. We're going to go through several examples of analyses in the Intezer platform, Intezer Analyze. But first, I will explain a little bit about the technology to make sure everyone here is on the same page. After those examples, we will have time for Q&A, and the whole webinar is supposed to take about 30 minutes. So please feel free to write down your questions in the Q&A comment, and don't worry, the questions are only available for us, the hosts, to see. So please feel free to write anything you want. And in the end, we will leave some time for questions. Okay, so let's begin. I will just open this slide, and this is going to be a very short explanation of how our technology works. So Intezer Analyze works on a technology which we call Genetic Malware Analysis. This technology provides malware classification based on code reuse in the binary level. This is very different than the common malware analysis or malware detection solutions out there, which are usually based on some sort of signature-based algorithm or behavior/anomaly detection solutions. These are great solutions, of course. There are many great technologies out there. We just have a fundamentally different approach. We know that every developer out there, whether writing trusted software or malware, reuses code on a constant basis because that's the right way to work from a developer's perspective. If it already exists, there's no reason to write it from scratch. So we see these pieces of code being reused between different versions of software and different variants of malware. Our technology is able to discern these connections and provide you with classification based on code reuse. So the process is very simple. We take an unknown file. We are able to extract what we call genes from the file. These genes are, in essence, just small pieces of binary code that we extract automatically from every binary file, and then compare those genes to a huge database we've created, we call the genome database. This database contains billions of genes, which are all categorized based on where they have been seen before. So when we do this comparison, in the end, what we get is a genetic profile of the file, which shows you exactly which pieces of code have been used in malware, and at that, exactly which malware family. And the same goes for trusted software. So we can provide classification. This process is entirely static, so it's very fast as well, and provides great insights. So after going through this really short explanation, let me show you an example because this is what we are here for. So this is our file analysis platform. We provide here in Intezer Analyze the ability to upload PE files, ELF files, and Android APKs. For PEs, we support native, non-native, that is .NET files. And for ELF, we support both native ELF and ARM as well. We don't support documents, PDFs, etc., because these are usually the delivery mechanisms for the malware, and we focus primarily on the binary payloads themselves. What I did just now is upload a file, a sample of malware. We can upload a file. We can also look up a hash and find existing analyses in the database. So what you can see here is the initial analysis, and also you can see that this file is packed. This is very important because you see that here on the left, dynamic execution, which is intended for unpacking, is already running. The initial result shows us a majority of generic malware genes, which are not that informative. We don't get a lot of information here, and a small connection to Emotet, which we also see here shown as a malicious packer. So we can understand from various pieces of information here in this initial analysis that this file is packed. Packers are used to hide the actual payload of the file and to make static analysis solutions like this less successful. But once we detect that the file is packed, what we need to do is attempt to unpack it. What we do in this case is send the file to a sandbox. We call this process dynamic unpacking or dynamic execution. If it doesn't happen automatically, you can also force it using the button here. And what this does is detonate the file on a remote machine. When that happens, the file has to unpack itself in order to load its code to memory in order to execute. And once it does that, we directly dump the process and all of the related memory modules. We dump their code and analyze them statically. So what you see on the left is the process tree that was generated from this file. And here in the middle, you can see that suddenly we have more genes that were extracted, and we have a clear connection to Emotet. Now, Emotet is a very common banking Trojan. If you click on the family, you can see this information here and get some references. And what you also get is a list of related samples. This list is based on the same genetic technology. So these are just many different files that were uploaded to our system and share a piece of code with this Emotet sample. So what you can see is that there is a huge amount of samples that share code with this variant and are in essence just different versions of Emotet. So when you base your detection and classification on code reuse, you don't need to run after all of these hashes. You just need to look for the code. Every sample here, you can access the analysis itself or download the file and even look at the actual assembly code behind the scenes here that was deemed related to Emotet. To the reverse engineers or malware researchers among you, we also have an IDA Pro plugin that provides even deeper insights in the function level, where you can see the actual connections to Intezer, the Intezer genome on the IDA platform itself. But this shared code feature provides you with a quick view of the assembly code. You can see more Emotet payloads extracted here, showing different connections to other pieces of malware. You also see string reuse. So these are just strings that we extracted from the file, and we also divide them based on where they have been seen before. Of course, the string information doesn't affect the final verdict of the file, but you will see in next analyses that I'm going to show that this information is significant when you have the ability to focus on the relevant strings. Apart from that, you also see more related samples. In this case, these related samples are related to my own previous uploads. So we don't only show the related samples globally in our database, but we also show the related samples to your own previous uploads for you to understand if, let's say, you're handling an incident right now and you're uploading a file and you see that you've uploaded a related file 6 months ago. That can really significantly save time in investigation and make you understand that you might be dealing with something you've seen before. In this case, you can see that I have uploaded my fair share of Emotet samples. So this is a quick overview of this result. Of course, we can get in much deeper, and there are many other features here that I haven't mentioned. But stay tuned to the end of the webinar, and I'm going to talk about the next webinar that we're going to do, where we'll focus even more on these advanced features. Now, I'm going to move over to the next analysis. This analysis is actually different in the fact that this is an endpoint analysis. If you look here, you can see that we have the scan endpoint option. So what this provides you is an endpoint scanner. This is a lightweight executable that you can run on any Windows machine. And what it does is collect all of the running code in memory. So it collects all of the processes, memory modules, and uploads them directly to our cloud and provides you with an analysis in the context of a full endpoint. So this really provides you with full memory analysis without any manual work except for running the scanner. And the entire analysis is usually done in about 5 to 10 minutes. What you can see here is we found 3 malicious modules and 40 trusted modules. Most likely that all of these trusted processes are just Microsoft processes, Windows processes, which is very normal to see on a Windows machine. Now, what we can understand from these malicious modules is that, again, we have Emotet infecting here the machine, and we can understand using this process tree view that is unique to the endpoint analysis feature that we have this process that actually detonated this malware. And we have a file here. You can see on the right here that this is an actual file from the disk, where you see here again a generic malware connection. And this is actually, again, a packed file. And 2 modules were injected to memory. So in essence, they were unpacked and executed in memory. So we can see both of them here as well. And I'm not going to dive too deep into this analysis because we've seen Emotet in the previous one, but it was important for me to show you the analysis for a complete endpoint. This is available for community users as well. Now, the next sample is a bit different also this time because it is not a Windows PE, but an ELF file, which is native for Linux. And we have great support for ELF files, and we've actually found many different Linux malware in the past year or so, and you are welcome to check out our blog about it. We have different researchers there. And in this case, you can see that not only this is an ELF, it is also packed by UPX. UPX is a quite basic packer, which can be mostly unpacked statically. And in this case, we can see that this was detected here. And initially, because this is packed, no genes were actually extracted, but still there are several strings that have been related to Mirai. Mirai is a very known botnet in the Linux world. Now, as you can see here, differently than the previous analysis we've seen, we see static extraction, which doesn't require any execution because of the type of packing we're handling here. Now, you see that genes were extracted once the file was unpacked, and you see that the major connection here is Mirai. Now, again, you can click, you can see more information, related samples to Mirai, and there are many of them, and even the shared code in assembly. Now, an important thing to know when investigating Mirai malware is that Mirai's source code has been leaked several years ago, and since then we've been seeing almost every Linux malware sharing some piece of code with Mirai, because when you have it, you don't need to write it from scratch. So you already see some related malware families to this Mirai sample, and this completely makes sense. These are many times open source malware that share with each other, and this is very obvious here in this case. Now, just to show you some interesting strings, you can see in the unique strings here, and unique means that these strings haven't been seen before in Mirai samples, at least for us. You can see a very interesting string here, which incorporates an IP address And actually, from a quick glance, you can understand that using wget, some file is being downloaded from this remote server. This is the path of the file /tmp/xb. And after that, the file itself is being executed after being downloaded. So this looks like either a piece of additional malware being downloaded, or maybe a reverse shell, but the strings provide very useful information in this case. Moving on to the next sample, you can see a malware called Bitpaymer. I actually haven't heard of it outside this week because there was a very large attack against the largest radio network in Spain, actually, and a few other companies in Spain, using this malware, Bitpaymer, which is a ransomware. Which is very common these days. And you can see that initially, again, this file is also packed, but just even for the packed file, we see a very clear connection to Bitpaymer. Once the dynamic execution has been run, you can see that even more genes have been extracted, and we also see more connections to other families. So we see genes that have been used in other ransomware that we've seen, and also in Dridex and Emotet, which are usually used as banking Trojans. So we can also look at the strings here, but in this case, I don't see any interesting information except for this file path. I'm sure this is some sort of text message that is, or text file that is provided to the victim in this case, with instructions of where to pay their fee. Now, interestingly enough, you also see in the dynamic execution section some process names that can explain a bit of what's going on. So takeown.exe is used to change ownership of files in the systems, and iCackles is used for changing access control, so permissions. So this totally makes sense in the context of ransomware. So of course, if you've been hit with this attack, I encourage you to upload the sample here or analyze it to be sure with which attack have you been hit, and get some more information, and hopefully be able to decrypt the files that have been encrypted. Now, the last analysis I want to focus on is a bit more advanced. We have many different stages here, and I want to go over each stage. So starting with the top original file here, which is again packed using a malicious packer, we can see that there is a small amount of genes that was extracted, and there are many similar connections here. So this even looks like the exact same code being used both in AutoKMS, Gorgon Group, Schoolgirl, Scrop, etc. Now, what this says to me as a person who's been working with Intezer for a while is that these are all actually packed sections of code. So this is the actual packed file. And the fact that we see various connections means that this packer has been used by all of these threats. So we've seen this packer used by multiple actors. So this can say to me, this is not a customized packer. It probably has been used by different threats in the past. So unpacking is in order. So you can see that the first layer here shows us some more generic malware genes, some administration tool code, in this case from NG Software. And we can actually see in the related samples that the software that has the largest connection here is called Master Remote. And from a quick check, you can see that these are remote connection tools, which makes sense to be used as part of an attack to provide remote connection. And also, if we look quickly here in the strings, you can also see references to a miner, so probably some sort of cryptocurrency miner, which might be used here as well. Now, moving forward, we see a new payload with a major connection to Snowjan. Snowjan is usually used as a downloader for additional payloads and malware. And in the strings here, we can go over all of them, but just quickly, I want to show one interesting string that actually creates a scheduled task running an executable, which looks like a fake LSAS process every minute from the look of it. So classic persistence mechanism. And lastly, after all of these have been executed, we start seeing Ramnet payloads. So Ramnet is usually used as a banking Trojan. It has moved through different phases. And as you can see in the description here, it is usually distributed via exploit kits. And this looks like it matches what we see here. So we can see multiple Ramnet payloads with different amount of genes and different code, and they probably have different purposes as well. And just from an initial look at the Ramnet strings here, what we can see is references to information on connected USB devices, which makes sense in the context of Ramnet because it is known to infect or spread through connected devices that may move from machine to machine. So here you can see that it is most likely scanning for connected devices in order to infect them as well. So as you have been able to see, we have different capabilities here in Intezer Analyze. You can upload various types of files and get very interesting results and get insights very quickly. So you can understand the classification of the file, the infection process, and the different stages involved. And without too much technical knowledge needed, you can get a lot of actionable intelligence and actionable data that you can use to protect your environment. Now, just a teaser for the next webinar, which we will focus more on our enterprise capabilities. So all you've been able to see so far is completely available to our community users. As you know, we have a free community edition where you can join for free and upload up to 10 files a day and scan an endpoint once a day as well. But we have several advanced features. For instance, you have the vaccine feature, which can enable you to generate Yara signatures automatically based on the code, the malicious code that we find, and this is also very fast. It can be used for hunting. It can be used for responding to an attack and containing it. You also have the ability to index your own code using private indexing, which means that if you have any proprietary software, you can define its own connections and customize your genome database. And we also have, of course, the IDA Pro plugin that enables you, as I mentioned before, to really accelerate reverse engineering and see the classification from Intezer directly over the IDA platform. So with that, I really want to thank you very much for listening. And I'm going to look at the questions. So just one moment. Okay, so I have a questions here regarding mutexes and if we can see mutexes to use for Yara rules. So I would suggest using our Yara rule generation feature, which enables you to generate automatically these Yara rules. And for mutexes, I would suggest looking at a sandbox solution, even VirusTotal, which provides all the mutexes you need. Okay. Any more questions, guys? Please feel free to add questions here in the Q&A section. Okay, I see a question here regarding memory analysis and whether it's we are able to process full memory dumps. So that's actually a question I get a lot. So as you've seen, we are able to provide full memory analysis using the endpoint scanner. And that requires, of course, running our scanner on the endpoint, but many times you don't have access to the endpoint, or you've just received a memory dump file to analyze yourselves, and you would like to use Intezer to analyze it. So we don't support direct upload of full memory dumps, but I do want to show you an example of how you can actually analyze memory dumps using Intezer. So let me just open a CMD here. Just one moment. Okay, so I have a memory dump file here, and I can use volatility actually to look at the processes that were available on this memory dump. Now it's pretty clear what I'm going to find here, but I can actually dump those processes as files to a directory. Let's hope that my antivirus is indeed disabled. And you can see that I dumped all of these files from the existing memory dump to a directory. And what I can do now is use our Intezer Analyze CLI to upload all of these files directly. So what I need to do is use Intezer Analyze and ask for analysis of the directory called dump. So what happens here, the CLI enables me actually to not only upload individual files, but actually to choose a full directory and upload all of the files available there directly to Intezer. So you can see that 19 analyses were created and one file was not supported. So if I want to see the analyses that are currently being done, I can look at the history page, and you can see that all of these executables were uploaded and already scanned. And we can see two malicious results here, which show connections to WannaCry. So you can see this WannaCry sample and this WannaCry sample, which are a bit different in this case. Okay, I can see another question here. Just one moment. So we have a question here regarding what we can do when you already have traditional malware software solutions. How can you use Intezer to actually expand on that? So actually, most of our customers use other solutions. Of course, in cybersecurity, you can't get enough of security solutions, but we have an open REST API that you can use both in the community and also as an enterprise customer. We have existing integrations with orchestration systems, with SIM systems, where we attempt to accelerate and automate incident response. But you can also integrate with other malware solutions. So you can create a pipe of automatic investigation, go through signature-based sandboxes, Intezer, however you want. So this is what the API is for. And I hope that answers the question. Okay. Also, I see that you ask if it replaces any solution. So Intezer provides more information, but different information at that. So the known threats are easily detected using signatures. We target the more advanced threats usually. So I would add it on top, but it really depends on the existing pipe that you have. Okay. Last minute for questions. Okay, if there are no additional questions, I want to thank you all for joining. Oh, here we have a question. Just one moment. Okay, I'm not sure regarding this question, so let me answer you offline. I'll send you an email and we can talk about this further. Just to remind also everyone, if you have any questions additionally, please feel free to contact us either at support@intezer.com. You can email me directly at shaul, SHAUL, @intezer.com. And I'll be happy to talk with you, provide more information, additional demos, and of course, tune in to our next webinar, which will focus more on our advanced features. So thank you everyone for joining. It's been a pleasure, and looking forward to seeing you in the next webinar.